This is the Spring 2013 Student Performance Analysis for the Algebra 1 Standards of Learning Test. Statewide results for the Spring 2013 Mathematics SOL tests have been analyzed to determine specific content that may have challenged students. In order to support preparation of students for the Algebra 1 test, this PowerPoint presentation has been developed to provide examples of SOL content identified by this analysis. While some of this content was first introduced in the 2009 Mathematics SOL, other content is included in both the 2001 and 2009 Mathematics SOL. There are also many similarities between the content identified during this analysis and the content identified during the Spring 2012 Student Performance Analysis. This PowerPoint presentation contains concrete examples of the content for which student performance was weak or inconsistent. These items are not SOL test questions and are not meant to mimic SOL test questions. Instead, they are intended to provide mathematics educators with further insight into the concepts that challenge students statewide. It is important to note that the SOL and examples highlighted in this presentation should not be the sole focus of instruction, nor should these suggestions replace the data that teachers or school divisions have collected on student performance. Rather, this information provides supplemental instructional information based on student performance across the Commonwealth of Virginia. The first standard being highlighted is SOL 8.1. This standard reads, the student will represent verbal quantitative situations algebraically and evaluate these expressions for given replacement values of the variables. For SOL 8.1, students need additional practice translating expressions. This example asks students to select each phrase that represents a verbal translation of the expression shown. Two of the answer options translate this expression and are boxed in red on the screen. If students are presented with two options similar to the options highlighted in yellow, they have difficulty recognizing how these options differ and do not recognize the last option as a correct translation. For SOL 8.1, students also need additional practice evaluating expressions with cube roots, square roots, and the square of a number, particularly when the replacement variable has a negative value. The answers to the examples are shown on the screen. For example A, a common student error is to add negative 36 rather than 36. Similarly, a common error for example B is to subtract negative 9 rather than 9. For example C, a common error would be to calculate the value under the radicand as negative 36 plus 64 rather than 36 plus 64. It is important that students recognize the difference between squaring a negative number and squaring a number and taking its opposite. For SOL 8.1, students need additional practice evaluating expressions that contain an absolute value. A common student error is not taking the absolute value of the quantity inside the absolute value sign when that value is negative. For example, in problem A, this error would result in multiplying negative 2 times negative 5 to get a value of 10 rather than multiplying negative 2 times 5 to get a value of negative 10. The answers to the examples are shown on the screen. The next standard being highlighted is SOL 8.2. For this standard, there were several areas of inconsistent performance. Students need additional practice performing operations on polynomials including A. Applying the laws of exponents to perform operations on expressions, B. Dividing polynomials, and C. Factoring completely first and second degree binomials and trinomials in one or two variables. Graphing calculators will be used as a tool for factoring and for confirming algebraic factorizations. For SOL A.2a, students need additional practice applying the laws of exponents to simplify expressions. The examples on the screen show some areas of student weakness. For example A, many students will calculate the power of the variable correctly, but will incorrectly calculate the coefficient by not raising the 2 to the fourth power. Similarly, in example B, many students will incorrectly solve this by dividing 30 by 6 to get 5 and then not square the 5. Example C is shown because students need more practice recognizing any value raised to the 0 power is 1. And finally, example D is shown because students need additional practice simplifying expressions with negative exponents. Students did well on items that required applying the basic rules, such as addition or subtraction of exponents only. For example, students would perform well on example B if the question only asks students to simplify what is inside the parentheses. The answers to the 4 examples are shown on the screen. For SOL A.2b, students need additional practice dividing polynomials. Students perform better on simplifying polynomial expressions that involve addition, subtraction, and multiplication, but do need additional practice with dividing polynomials. It would be helpful for students to practice this skill in a non-multiple choice format. The answers to the questions are shown on the screen. For SOL A.2c, students need additional practice completely factoring polynomials, particularly when there is a greatest common factor. For the example shown, many students would not recognize that the greatest common factor of 2 is indeed a factor. It is also important to note that 4x squared minus 9 can be factored into the quantity 2x plus 3 times the quantity 2x minus 3, and is therefore not a factor of 8x squared minus 18 when it is completely factored. The answer to the example is shown on the screen. Here is another example for SOL A.2c. Students need additional practice using the x-intercepts from the graphical representation of the polynomial to determine and confirm its factors. Most students can answer questions that require selection of a factored equation from a list of answer options to match the given graph. However, it is more difficult for them to create the equation from a list of factors. The answer to the question is shown on the screen. The next standard being highlighted is SOL A.3. This standard reads, the student will express the square roots and cube roots of whole numbers and the square root of a monomial algebraic expression in simplest radical form. In the Spring 2012 Student Performance Analysis, students had difficulty understanding how to calculate or simplify the cube root of a whole number. Students did much better on those concepts during the Spring 2013 test administration. Students are also doing very well at calculating and simplifying the square root of a whole number. However, performance on simplifying the square root of a monomial algebraic expression in simplest radical form was inconsistent. For SOL 8.3, students need additional practice simplifying the square root of a monomial algebraic expression. Students would benefit from experiences that require them to simplify monomial expressions that do not have perfect square coefficients. The answers to the examples are shown on the screen. The next standard being highlighted is SOL A.4. For this standard, students need additional practice with bullet A, solving literal equations, formulas for a given variable, bullet C, solving quadratic equations algebraically and graphically, bullet D, solving multi-step linear equations algebraically, and bullet E, solving systems of two linear equations in two variables algebraically. For SOL A.4a, students need additional practice solving literal equations. The answers to the two questions are shown on the screen. For SOL A.4c, students need additional practice finding solutions to quadratic equations presented algebraically and graphically. The answer to the question is shown on the screen. Here is another example for SOL A.4c. Students don't seem to understand that the word solution is where the graph of the quadratic equation crosses the x-axis. Students will erroneously plot the y-intercept as a solution, and many times they will also plot the maximum or minimum as the solution. The answer to this question is shown on the screen. For SOL A.4d, students need additional practice describing solutions to equations that have the following solutions: x equals 0, an infinite number of real solutions, and no real solutions. The answers to the examples are shown on the screen. For SOL A.4e, students need additional practice finding solutions to systems of equations presented algebraically. Students are better at identifying the solution to a system of equations when the system is presented graphically. However, when the system is presented algebraically, students have more difficulty. In the first example, students are asked to identify a system of equations with no real solution. Students should be able to compare the slopes of the lines in each system to determine whether the lines are parallel. The second question asks students to find the x value of the solution to the system of equations. The answers to both questions are shown on the screen. The next standard being highlighted is SOL A.5. This standard requires students to solve multi-step inequalities in two variables. Specifically, students had difficulty with bullet A, solving multi-step linear inequalities algebraically, bullet B, justifying steps used in solving inequalities, and bullet D, solving systems of inequalities. For SOL A.5a, students need additional practice solving multi-step inequalities. One way in which this standard is assessed is identifying where a mistake has been made in the steps shown for solving. The answer to this example is shown on the screen. An extension could be to incorporate practice for SOL A.5b by asking students which property justifies the work between two consecutive steps. For SOL A.5b, students need additional practice identifying properties of inequality. This question asks students to identify all inequalities that illustrate the subtraction property of inequality. The answers are shown on the screen. As an extension, ask students to identify the property illustrated by each of the answer options not selected. For SOL A.5d, students need additional practice identifying ordered pairs that are solutions to a system of inequalities. Students do well when selecting solutions from a graph or when asked to shade the region of the graph that is the solution to the system of inequalities. They do not do as well when they have no visual representation of the system. The answers to the example are shown on the screen. The next standard being highlighted is SOL A.6. For this standard, students need additional practice determining the slope of a line when given an equation of the line or 2 points on the line, and they also need practice when writing the equation of a line when given the graph of a line. For SOL A.6a, students need additional practice finding slope. Equations should be presented to students in different formats. The answers to the questions are shown on the screen. Here are 2 more examples for SOL A.6a. In the second example, students will need to think about the x-intercept as a point in order to find the slope of the line. The answers are shown on the screen. Here is another example that contains questions that are correlated to standards A.6 and A.7. The answers are shown on the screen. Here is another example for SOL A.6b. Students would benefit from experiences graphing an inequality presented in varied formats. The answer is shown on the screen. The next standard being highlighted is SOL A.7. In particular, students need additional practice finding domain and range, the zeros of a function, and x and y intercepts of a function. For SOL A.7b, students need additional practice identifying the domain and range from a graph. It is important for students to recognize that the range for this set of points consists of discrete values, as indicated on the screen, and is not a range of values, as indicated in option B. Here is another example for SOL A.7b. The answer is shown on the screen. For SOL A.7c, students need additional practice finding zeros of linear functions. A common error is for students to substitute 0 into the equation for the variable x, erroneously selecting the y-intercept as the location of the 0. The answers to the questions are shown on the screen. For SOL 8.7c, students also need additional practice finding zeros of quadratic functions presented algebraically. The answers to the two examples are shown on the screen. For SOL 8.7d, students need additional practice identifying the x and y intercepts of a function. For this example, students are asked to find both the x and y intercepts of a linear function. The answer is shown on the screen. Here is another example for SOL 8.7d. This example asks students to plot the x and y intercepts of a relation presented graphically. The answers are shown on the screen. The next standard being highlighted is SOL 8.8. In particular, students need additional practice representing direct and inverse variations algebraically. For SOL 8.8, students need additional practice selecting ordered pairs from a list to make a relation that is a direct or inverse variation. The answers to the examples are shown on the screen. In addition, students need to be able to identify which set of ordered pairs, when presented as answer options, represent a direct or inverse variation. For SOL 8.8, students also need additional practice identifying a direct variation equation algebraically and graphically. The answers to the example are shown on the screen. Here is an example that requires identification of a graph of a direct variation. The answer is shown on the screen. The next standard being highlighted is SOL 8.9. This standard reads, the student, given a set of data, will interpret variation in real-world contexts and calculate and interpret mean absolute deviation, standard deviation, and z-scores. In particular, students need practice calculating and interpreting standard deviation and z-scores. For SOL 8.9, students need additional practice performing calculations with statistical information. The answers to the two examples are shown on the screen. Here is another example for SOL 8.9. This example asks students to identify an interval in which a data point lies. Intervals can be presented graphically, as in this example, or algebraically. The answer to this question is shown on the screen. The next standard being highlighted is SOL 8.10. This standard reads, the student will compare and contrast multiple univariate data sets using box and whisker plots. Students have difficulty with many aspects of this standard. For SOL 8.10, students need additional practice interpreting data plotted in box and whisker plots. Students struggle with vocabulary such as range and interquartile range. They have difficulty calculating and comparing the range and interquartile range of two or more plots. Students also need practice comparing plots that have a specified number of elements. For instance, the third question requires students to sketch out plots A and B and determine how many elements of each plot meet a given criteria. The answers to the questions are shown on the screen. Here is another example for SOL A.10. This question requires students to determine how many data points in each plot meet a certain criterion. The answer is shown on the screen. Here is an example that requires students to determine the effect on a box and whisker plot when an element is added to the dataset. Paying attention to the location of the new element within the original dataset helps students determine whether or not certain conclusions can be drawn. It is very important for students to realize that some statements cannot be proven true using the box and whisker plot, since the elements themselves are not given. Students must draw conclusions based only on the information that is given. For instance, the statement, "The interquartile range of the box and whisker plot increases," may be true or false depending on the dataset. Likewise, the location of the median of the dataset will change, but the value of the median may or may not increase. The only two statements that will always be true are the ones indicated on the screen. The next standard being highlighted is SOL A.11. In particular, students had inconsistent performance making predictions using the curve of best fit. For SOL A.11, students need additional practice making predictions using the linear or quadratic curve of best fit. Students performed better when they had to predict from a graph or find the equation of a line of best fit when the data points were presented on a graph. When data was presented in set form or in a table, students had more difficulty finding the curve of best fit and making a prediction. The answers to the questions are shown on the screen. Here is another example that asks students to predict a value using the quadratic curve of best fit. Similar to the last example, students should determine the quadratic curve of best fit using the graphing calculator and then use that curve to predict the value of the account at the end of 13 months. The answer to the question is shown on the screen. Here is one last example for SOL A.11. The answer is shown on the screen. This concludes the student performance information for the Spring 2013 Algebra 1 SOL test. Additionally, test preparation practice items for Algebra 1 can be found on the Virginia Department of Education website at the URL listed on the screen.